Satellite internet. Connecting the world from space. Satellite internet is a type of wireless internet service that uses satellites orbiting the Earth to deliver internet connectivity to users, especially in remote or underserved areas. Unlike traditional broadband services that rely on cables, fiber optics, or telephone lines, satellite internet beams data directly from satellites to a dish installed at a user's location. How it works. Satellite internet operates through a network of three main components. Satellite in space. Typically placed in geostationary orbit, about 35,786 kilometers above Earth, or low Earth orbit LEO. As low as 550 kilometers, satellites act as relay stations for internet signals. Ground station, gateway a terrestrial station, transmits internet data to the satellite, which then relays it to the user. User terminal, dish, and modem. A satellite dish installed at the user's home or business receives a signal, and a modem translates it into usable internet access. Key features. Wide coverage. Satellite internet can reach areas where traditional infrastructure is unavailable, such as rural, mountainous, or oceanic regions. Quick deployment. Unlike laying cables, satellite internet can be set up rapidly with the right equipment. Always-on connection. It provides a constant internet link, ideal for areas prone to network outages. Advancements in satellite internet. Modern satellite internet has seen major improvements, especially with the rise of low Earth orbit LEO, satellite constellations from companies like Starlink, SpaceX, OneWeb, and Amazon's Project Kuiper. LEO satellites orbit much closer to Earth, resulting in lower latency, faster response times compared to traditional geostationary satellites, higher speeds. Many LEO providers now offer broadband-like speeds suitable for streaming, video conferencing, and online gaming. Better reliability. Multiple satellites in orbit ensure stronger and more consistent coverage. Pros and cons. Advantages. Access to internet in remote and rural areas. Independence from ground-based infrastructure. Ideal for disaster recovery or mobile environments, e.g., ships, military. Disadvantages. Latency, delay in data transmission, especially in geostationary systems. Weather sensitivity. Rain, storms, or snow can affect signal quality. Data limits. Some providers may have usage caps or slower speeds after a threshold. Applications of satellite internet. Rural and remote connectivity. Bringing internet to underserved regions. Disaster response. Restoring communication quickly after natural disasters. Maritime and aviation. Offering onboard internet for ships and planes. Military and government. Supporting secure and flexible communications.